Okay, Advent of Code Day 3. Day 3 Rucksack Reorganization. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, the elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has two large components. All items of a given type are meant to go into exactly one of the two compartments. The elf that did the packing failed to follow the rule for exactly one item per rucksack. The elves have made a list of all the items currently in each rucksack, but they need your help in finding the errors. Every item type is identified by a single lowercase or uppercase letter. Okay. The list of items for each rucksack is given as characters on a single line. A given rucksack always has the same number of items in each of its two components. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose we have the following list of contents from 6 rucksacks. There are 6 rucksacks, each have 2 parts, and they're all, and it's the same number, so it's all going to be even length. The first and second, and the only thing in common is P. Okay, that makes sense. To help prioritize items rearrangement, every item can be converted into a priority. Okay, let me see if few things. That's funny. Let's go to ASCII. Let me see a few things. Okay. So they are next to each other. 65 and 97. Okay. They are next to each other. So that is C++ is upper? It is just is upper. Yes, I was right. Okay. Find the sum of the items that appear in both compartments of each rucksack. What is the sum of the priorities of those items? Okay, so each rucksack can only have items of one. No, each compartment can only have all items are good. Okay, can it be the case where we have two P's in both, or does each compartment have to be fully unique? I know they're not going to one or two compartments. Okay, so let's just okay, so let's do one thing. So let's set everything up. Boom. Let's go back to C++ and save this as AOC 2022 day 3. Let me copy this and put here. So actually, what's our input? No, just a list of lines at this point. Okay. So let's. So answer here should be 1. So let's change this, my friend. So let me just debug stir and see what we get as the output for now, just to ensure things are working as expected. Cool, everything is the last one is CR's. Yep. Okay, now that that's the case, part 1 and equals start at 0 all the way until dot size over 2, and the other, and then part 2 would be string dot substring from s from string dot size over 2 onwards. And now if you debug string p1 and p2, everything should be as expected. V all the way to CWI and HCS. Okay, yep, everything is as expected. So now we have a total score which we want. And what we can say is what we can do is just have a map. So we can have a map that goes character to integer, which will be the character we see and the number of times we see at the count. So just do error and count, right? So then we only care about p1. So if for char c for the character in the string p1, mpc is add a counter mpc. So we just want to count the number of times we see characters in string 1. So now we can go to string 2 and just find the duplicates. In p2, if we have seen this string, then we have to add it to our score. So then if is upper C, so if the score plus equivalent of C minus A plus A is how much? They mentioned A is gonna be 27. Otherwise it's in lowercase, so then we just add C minus A plus 1. Then we see out the score. So you run this, get 237, which is not what we want. We want 157. Let me do one thing. Then debug. I want to see at this point what the current string is and what the character is. What do we see? It's PL PVTS. There are multiple times it's there. It doesn't matter, they only care about the character itself. So we want all the unique characters. So okay, so now the issues we are double counting. So we see if MPC we add it to our score, and then we set MPC as 0, so we don't double count. Now this should be fine. 157 is what we have. Cool. Now we get our puzzle input. Put that in input, and we run 8105. Okay, that's right. Part 2. As you finish identifying the misplaced item, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item carried by all 3 elves. That is, if a group badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item. Okay, that's good to know. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges needed to be pulled out of the rucksack so the new stickers can be attached. Additionally, nobody wrote down the item which corresponds to each group's badges. The only way to tell which item is the right one is by finding which item is common between all 3 elves. Every set of 3 lines in your list corresponds to a single group, but each group can have different badge item type. So in the above example, the first group rucksack are the first 3 lines. These are the next 3 lines. First group, the only thing common in all 3 is R, and the only thing common here is Z. Prioritize for these items must still be found. Organize the sticker attachments. Here they are 52, the sum of these is 70. Oh, so just be... Oh, just groups of 3 now. Input is... Okay. Okay, so there's a very simple way to deal with this. Let's have a vector string vs, and then so while vs dot size what we do is at this point we do vs dot, we're going to push back the string we get, then if vs dot size is 3, which is what we want, whoops, we can start solving here. Then at the very end of this we set vs dot clear, and I think that should be the basis. So now we get every 3 in this, and so we do the exact same thing here. So we don't care about part 1 and part 2 anymore. We just want this map. So boom, boom, oops. And so what we can do is we don't care about part 1 and part 2. There you go. So for every character in the first out of 3 compartments, so we have 0, oh, I need that upper lower logic though. I can write it again, but if I have it, might as well use it. for every character in the first string, MVC we add +1 to that, and we do the exact same logic for VS1. And now what we do is for char C in the final percent item, if the current count of this letter that we have, we're gonna have duplicates because this has 2 P's and this has 2 A's. So we just want it to be unique. So the way we can do that is make all strings have unique characters for string S in VS. We sort S, and then do I have the remove duplicate function that call unique? I don't have unique. I can just quickly nab that. Unique C++. Add them to a set. Yeah, I think that's a bit easier than dealing with the math here. So instead of having and so at this point we put a set of characters called set, and then delete all of that. Oh, we know this has to be maximum 1, has to be maximum 2. Interesting. But no, there are edge cases here. Ooh, let me think this through to the more elegant way. Do we have a set, right? And then we see the character, but for each person, by mistake, the same character can appear twice. We can brute force it. I think that's that is what I'm gonna do. So let's ignore this set stuff to deal with. So map 2 and map 3. A vector would work here, a set would work also. MP1, MP2, and then make this MP3, and then we do for character A to Z. How does that work? Like, I forgot. C++ iterate through A to Z. What is a nice way to do it? Oh, this is the way. For C in alphabet? Oh, interesting. Can you do that? For turn. Okay, yeah, you can't do that. So we do for char x between ax is less than equivalent to z plus plus x, because characters are treated as integers. If mp1 x and mp2 and mp3 x score plus equivalent to x minus a plus 1, and now let our character y be 2 upper x. Do the exact same logic. Except we change the x's here to y, and this what just becomes y minus a plus 27. This is one index, and this starts at 27. For character x equals a, x is less than or equivalent to z. Oh, ooh. Okay, 16430, but is this even right? Let's check with this. We expect the answer to be, oh, whoops. We expect this answer to be 70. Okay. They also to clear the map at the very end. Map.clear. Oh, to clear all 3 maps. MP2 and 3. This is not the best way to do it. Why? It's still 258. Debug. MP1, MP2, MP3, and then VS. What do we get here? All these are empty. And right before, what do we see? It's very interesting. So what do we get in the output here? V, VJP, WT. Exactly what we want. So yeah, let's see what we find in common. Debug X, and then we can debug Y. Let's stick with the map debugging and only the VS. V1. Where's the 2 lines? Yeah. Each one's R, R, R. F, F, F. There's no F here. What does F get printed out? Let me just debug VS here to separate them, and then oh my god, it's an indexing issue. That's stupid. 70, yep, as expected. One 11561. Oh, that's incorrect. Look, I added some entries here. Oh, okay. I gave enters, that's why. So it's an enter here. Two, 3, 6, 3. Oh my god, and it just created that. Because it's still 2, 3, 6, 3. Did I just run the wrong algorithm? Maybe I did. 4 seconds. 3, 2, 1. Boom. Okay, we have finished day 3. Oh, I'm a bit rusty, and I'm not even coming up with the optimal solution. But hey, it's working. But yeah, that is day 3 of Advent of Code 2022.